Hello guys, welcome back. Now in this video, though I'm using the same dataset as I used for one-way ANOVA, I want to teach you about how to run a correlation. So remember, our data is normally distributed and this data is normally distributed, and we want to run a correlation. Let me say we want to get a relationship between, let me say, pH and dissolved oxygen and electrical conductivity, temperature and pH. We want to see whether they are varying within the sites. So what I do, simply I select analyze, then analyze. There's somewhere where there is correlate, so you select bivalent. When you select bivalent, you can just say Ctrl A, then you select all the variables. Then after selecting all the variables, you can click options. So option, you can just continue, there's nothing to do there much. So if the data was normally distributed, so you select Pearson and this data is normally distributed. Then if it wasn't, you select Spearman rank correlation. But you don't do both because data cannot be normally distributed and at the same time not normally distributed. So you select only one. Then test of significance should be two-tailed. So after that, you click OK. After clicking OK, so it is computing to find so the correlations are here. So it's correlating between site. So we want to see whether pH was varying within site. So here you are having within site, so between the same parameter it will give you 1. Pearson correlation is going to be 1, but this is not more significant to our study. So what we need is, let me say, between pH and dissolved oxygen. So we want to analyze what happened between pH and dissolved oxygen. So it is showing a negative Pearson. So here you are having Pearson correlation. This is a sig value here. Then this is n. N is the number of samples you collected or number of values you are having. So Pearson correlation for pH and dissolved oxygen, it is negative 0.574. What does this one mean? It means there is a negative relationship between pH and dissolved oxygen. Or let me say, every time we have increase in pH, we have a reduction in the dissolved oxygen. And the sig value for two-tailed, it's giving us 0.025. What does it mean? It means that this negative correlation, which is somehow good, there was a significant relationship between pH and dissolved oxygen. And why am I saying it's significant? Is because this value 0.025, it is below 0.05. So it means there I can say that the relationship is significant. But let's have a look at this. So let's look at site and dissolved oxygen. So it's having the relationship, it is 0.108. What does it mean? This value, it is above 0.05. So the relationship is not significant at all, though it is negative. So guys, now let's see what if I selected Spearman rank correlation, though the data is normally distributed, and by mistake you select Spearman rank correlation. Let's see what would happen. So I'm going to select Spearman and press OK. So this will be the results of Spearman rank correlation down here. So I hope you can see and you can judge. We had pH with dissolved oxygen. If you can rewind, so there this relationship was significant, but here the relationship is not significant because it is above 0.05. it is 0.06. I think you can. So you have to make sure that the test you are running, it is, let me say, you follow all the criteria, all the principles before running that test. Let me say all the assumptions should be made. So when do we run Spearman rank correlation? It is when the data is not normally distributed. And when do we run Pearson rank correlation? It is when the data is normally distributed. So guys, you can copy these tables if you are interested in the Pearson, which is parametric. You take it to, you just right click here, then you copy, then you can paste it in Excel, and you can do any other thing you want. So guys, Feel free to subscribe to Best Science in Reality. Thank you.